Today I'm just going to give you a little bit of a review on solving logarithmic and exponential functions. And I have 4 problems here of which I'm going to go over. Now the first 2 have logs written in them, the second 2 do not, but they have the unknown as an exponent. Now here is the key feature, the key to understanding this. If it has a log in it, what you want to do is you want to get rid of the log by writing it in exponential form. I'm going to actually write exponential form. If it is in exponential form, so it's in exponential form, then what you need to do is either get the bases to be the same or get it in log form. So essentially, you have this exponential form and logarithmic form, and you're going to go back and forth between the two. If it's like this, you want it like this. If it's like this, you want it like this. So with that being said, the first one is in logarithmic form. It has a log in it. We want to get rid of the log by writing it in exponential form. In order to do that, this has to be isolated. The log with whatever follows it has to be isolated. Once it's isolated, so in other words, if anything were up here, you would have to get rid of that. Once it's isolated, you can then write it in exponential form, which is like this. This would be 4 to the 3rd power is equal to 2x plus 4. And then you can solve this equation. I'm not going to solve it because I think you can do that. Now, if you look at the second one, the second problem has 2 terms of logs. So we still need to get rid of the logs. And how we're going to do that is write it in exponential form, unless we can get 1 log equal to 1 log. But for this problem, we cannot. So what I need to do instead is I need to take and condense this down to just 1 log. So the rules of condensing this say the base is going to stay the same. We have addition, and we know addition goes with multiplication. So we are going to multiply this term times that. So this is going to be x plus 5 times an x. And that'll be equal to 2. Now in simplifying this, because I definitely want to simplify this first, I'm going to get x squared plus 5x. And of course that log with base 6 is still there. And I'm going to put the parentheses around that so you can see that's a quantity. Now I need to get rid of the logs by writing this in exponential form. So in doing so, I'm going to take 6 to the 2nd power, and that is equal to x squared plus 5x. Now this one I am going to go further because this is 36 equals x squared plus 5x. And I can't solve this problem without having one side equal to 0 because I have an x squared and an x term. So I have 2 solutions. So this is the same as x squared plus 5x minus 36, and that equals 0. I can now factor this, and it factors into x plus 9 and x plus minus 4. And when I set each part equal to 0, I get x equals negative 9 and x equals positive 4. Now, while these look like my 2 answers, remember I have to check, because if I get a negative value after the log, I get an error message because I can't take the log of a negative number. Because remember what the graph looks like, it's never negative. So when I plug in negative 9 here, I get negative 4. So immediately I have to throw this one out. The 4 is okay, and the 4 is okay there. So this is my only solution. Now, when I look at the bottom 2 problems, there are not logs in these. But in order for me to solve this, I'm going to have to introduce logs because I'm going back and forth between these 2. Now, remember there's also a shortcut, and this one you can use the shortcut. If you can get the bases to be the same, which I can in this, I can make this 3 to the 4th power. If I can get the bases to be the same, this is a shortcut. There's always a question like this on ACT. Because now the bases are the same, and now we know the powers have to also be the same. So here's my simple equation. 3x is equal to 4 times the quantity x minus 2. Or 3x is equal to, after I distribute this, 4x minus 8. And you can continue and solve that, and you would see you get an answer of x equals 8, which checks out. Now, this one I can't use the shortcut because I cannot make these bases become the same. So when I have that, I have to take and go from exponential form into logarithmic form. And in order to do that, I need to introduce logs, and I'm going to take the log or natural log of both sides. And it's my preference to use natural log. Once I do that, this allows me to punch this down and pull it in the front. So what I have is this. Now if I want to solve for this x, it's being multiplied to this natural log of 9, so I can simply undo it by dividing. And it's also being multiplied to this 3, so I can undo that also by dividing. And that 3 is going to join that natural log of 9 right here. When I plug this all into my calculator, that will give me the answer. And just a reminder, when you plug this into your calculator, is you have to do the natural log. I would recommend that you use the alpha and y equals button, so you have the fraction key on here. And then do the natural log of 10, close your parentheses, arrow key down, and then you can do 3 times the natural log of 9 and close your parentheses and hit enter, and there's your answer, 0.349. So it's approximately 0.349 right there. And that one's going to work because anything works, whether it's positive or negative as an exponent. So that's just a quick summary on how to solve these equations when you have all these different types. The only thing I didn't go over is if you have one log with any base equal to another log with that same base, like this. And remember, then these simplify away, and you have just 5x equals 5 as an equation, and then you could solve it. And that is when they're on opposite sides and there's nothing else added or subtracted. If they're on the same side, you should condense. If you ever have any other number besides that, you need to get the logs on that side and also condense. So there you have it. If you have questions, please reach out to me. Otherwise, have a great day, and tomorrow we'll work on the review and then we'll begin the test.